Hello. In this video, we're going to continue our study of logarithms. And just as a quick warm-up, I would like us to find log of 20 plus log of 5s with no calculator. In other words, we're going to use benchmarks here to just get some approximations. So remember, benchmarks means we need to find numbers that are nice. Log of 10, right? That's a nice number. That's going to be 1. Log of 100, that's a nice number. It's going to be 2. Remember, when there's no base, this means base 10. So log of 20 should be somewhere between 1 and 2. So, I don't know, maybe 1.2, 1.3, something like that. Maybe a little bit more, maybe a little bit less. It's hard to say, but we know it's somewhere between 1 and 2. And we know it's closer to 1 than it is to 2. Okay, let's do the same thing over here for log 5. Now, we know log 10 is 1, and log of 1 is 0. That's kind of like our nice number there. So this should be somewhere between 0 and 1. Again, we don't know exactly where it is. Maybe closer to 1 than to 0, so maybe 0.6, 0.7, something like that. So now we can add these two numbers together. 1.2 plus 0.7 equals 1.9. Okay, so we've got an approximation there for the value, but you know what? Let's just check our numbers. Let's check our numbers. So for fun, we're now going to use our calculator. Log of 20 is exactly equal to 1.301. Okay, it's kind of got that gross decimal feel. And our approximation of 1.2 is pretty good. Now, log of 5 is 0.699. Oh, we're actually pretty close to that 0.7. Okay. And now if we add these two numbers together, it's nice on your calculator to use all the decimals. So log 20 plus log 5 is going to equal... Oh. I got 2, like a whole number 2, no decimals. That's kind of weird because this is like, this right here is like gross decimal. And over here, this is like gross decimal. And you wouldn't think that if you added 2 gross decimals, you'd get a whole number. You'd think you'd get some other horrible gross decimal. But it looks like we get a whole number of 2. It's kind of interesting. Let's go ahead and explore this a little bit. Let's try log 50 plus log 2. So if you do log 50, you'll get 1.6989, some gross decimal. Log 2 is also a gross decimal. And then let's add those two together. Log 50 plus log 2. I get 2. Okay, log 70 over 3. Plus log 30 over 7. That also equals 2. Okay, let's try log 2 plus log 5 plus log 10. Oh, weird. That also gives me 2. It's almost like there's some kind of 2 rule going on here. Every answer just gives me 2. Now, what do you notice? Is there a pattern? I mean, I know they're all plus, but like this one has 2 terms, this has 2, this has 3. This one has whole numbers, this one has fractions. Like somehow all of these are giving us 2, but like why? And why 2? I'd encourage you pause the video and see if you see anything, if there's any pattern, any rule. All right, I want to maybe show you something that might help. We know that 2 is log of 100. Now looking at the numbers 2 and 5, do they combine to make 100? I think they do. I think if we took 50 times 2, we would get 100. I think actually if we took 70 over 3 times 30 over 7, we would get 210 over 21, which is 100. Oh, there's an extra 0 there. And I think if we did 2 times 5 times 10, we would get 100. So it's sort of like the three numbers we have, or the two numbers in the other cases, they multiply to give 100. And then if we were to sort of log it, well, log of 100 would be 2. It's almost like instead of logging the 50 and then adding the log of the 2, we could just multiply them first to get 100 and then log the whole thing. That's kind of interesting. If we were to write it out in symbols, it's sort of like this. Right? We have log of 50 plus log of 2 is equal to log of 50 times 2, which is log of 100, which is 2. And so this key step here, where you go from having 2 logs to just a single log, and where you go from addition to multiplication, we can write it like this. Log of A plus log of B is the same as a single log of A times B. And this is a very important rule. In fact, if you look on your formula sheet, you'll see something that looks very similar. It says log of M plus log of N equals log of Mn, which is, this is just same, just another way of writing it. So actually, this is a pattern. Yes, this is a pattern. This is a rule. This is called a log rule, and it works when you're adding two logs. They have to be the same base. But yeah, it works out. Let's go ahead and try some examples. Without a calculator, so I know with a calculator this would be easy. So without a calculator, determine this, this, and this. Go ahead and pause the video and give it a try. Alright, so assuming you gave that a try, what we could do is use our log rules to combine everything. So the bottom one has only 2 logs. Maybe that's a little easier for you. We could write this as log 2.5 times 4. Now 2.5 times 4, hopefully you don't need a calculator for that. You should get 10. And log base 10 of 10 is 1. Now the same idea applies up here if you have a lot of numbers. This would be log 5 times 5 times 2 times 2, which will be log of 100, which is 2. Or here, we would have log of 25 times 4 times 10, so log of 1000, which would be 3. Now, let's go ahead and investigate the same idea, but this time subtraction. So go ahead and try the following with a calculator and see what you come up with. Alright, so assuming you gave it a try, this one should give you 2. This one should also give you 2. This one will give you 2, and this one will also give you 2. Which is kind of silly. They're all giving you 2. Maybe when you subtract logarithms, you always get 2, but log of 300, I mean, as a decimal, that's 2.477. And log of 3, that's like 0.477. And I guess when you subtract these two, you do get 2. But why? Again, here, if we look, 303, right? The 2 on this side, we can think of this as like log of 100. So how do I get 100 using the numbers 303? The answer is division. 300 divided by 3 is 100. Or 2500 divided by 25 is 100. 50 divided by 1/2 is actually 50 times 2, which is 100. And 1200 divided by 3 and then divided again by 4 will be 100. And so the rule here is that you can just go ahead and take log, let me write down the 300 one, minus log 3, and write this as log 300 over 3, which is log 100 which is 2. Okay. And then we could write the general formula as log A minus log B equals log A divided by B. So again, when you have 2 logs, you can turn it into a single log, and the subtraction becomes division. If you look at your formula sheet, it's probably written a little bit differently. Probably looks like log m minus log n equals log m divided by n. But it's just using m's and n's instead of a's and b's. So go ahead and try these 3 questions. Come up with the answer without a calculator using this log law or log rule. All right, so assuming you gave these a try, what we can do is take the 2 logs and turn them into just a single log with division. Then we can work on the division. 400 divided by 4 is just 100. And log of 100 is 2. Same thing over here. This will give us 5,000 divided by 5, which is log of 1,000, which is 3. Here we'll have log of 10,000 divided by, well, both of them are subtract, so both of them go on the bottom for the division. It's going to give you log of 10,000 divided by 10, which is log of 1,000, which is 3. Now here's a really fun one. This uses addition and subtraction, so I'd encourage you pause the video and give this one a try. All right, so it has log base 60, but the log rules work no matter the base. The ones that are added become multiplication, and the ones that are subtracted become division. Now there's another multiplication, that 10, and there's another subtraction, that 2. So now we got to figure out this whole mess, but again, it's easier if we work the 14 and the 7, just give you a 2, and then the 2 2's can cancel with the 4. This is going to give us log base 60 of 6 times 10, which is 60. What power of 60 do you need to get 60? The answer is 1. All right. Now again, just for some quick notes here, we were looking at log rules. And so the first 2 rules are that log of A plus log of B is log of AB, with a multiplication there if you want to write it. Log of A minus log of B is log of A over B. And these work for if you have no base, which is base 10, or any base you want. Again, one thing to keep in mind, of course, is that when you're working with this, sometimes students get a little bit overeager. So if you saw log of, let's say, 4 plus 6, right? You can't write this as like log 4 plus log 6 or something crazy like that. The rule is that when you have 2 logs and an addition sign, it turns into 1 log and a multiplication sign. But if you have 1 log and an addition sign, you just have a log and an addition sign. You don't have the specific situation required to use the log rules. Now in this case, you could just do 4 plus 6, which is 10, and then that'll give you 1. But just be careful here. This basically, and again, I'm just going to cross this off so you don't even look at it. If you see log of 4 plus 10, the addition is inside the brackets and there's only 1 log, there's no rule to use here. You just kind of got to do something else. In this case, maybe add the numbers like normal. So for an example, let's try log base 4 of 2.5 plus log base 4 of 4 minus log base 4 of 5. So go ahead and evaluate that without a calculator. All right, so for your solution here, you should get 2.5 times 4 divided by 5. So that's going to be 2.5 times 4 is 10. So that's going to give me 2. And what power of 4 do I need to get 2? The answer is 1/2. It's the square root. Now for some more practice, you can look at Unit 9, Worksheet 2. And you can write down any things to remember. All right, hopefully you enjoyed this video. And as always, thanks for watching.